Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to day 19 of Advent of Code, with some remains of day 18, but we fixed the off by one mistakes from yesterday and I will tell you all about it. And with me here as always, David, hello.
Hello. Yeah, I'm very excited to see how you fix the issues. And I think what I'll do is I'll let you explain it to me. Now that I'm confident that we've understood it in the right way, I will go away and try and re-implement it myself, or salvage the implementation that we started with in Python. As presumably you did it in JavaScript?
You would be correct to presume that, yes. That's where the light is for me. So here is what is up. Bo is here. Hello. I hope you are having a wonderful morning.
Oh, thank you, Bo.
The shape that really made everything click for me was this. So naturally this is the area that we are digging. And the idea of Green's theorem, completely solid, and we understand it perfectly. It's simply a matter of all the off by one mistakes that you can make. So let's see how this goes. When you are going down, you add the tiles. So in terms of off by one mistakes, the way that I ended up doing this is that you don't count this row. So this would be a distance of 2 steps. If I am at this node going down, I am going down by 2 steps. And I have my x coordinate. So I will take my x coordinate and imagine that perhaps the y-axis is passing by here, for instance, okay? So what you're gonna do is you're gonna add all of this, which is distance, 2 steps, times the x coordinate.
Oh, so we're not.
Huh?
So we're not. We don't necessarily have to start at the 0,0 origin.
You will see. Yeah, I am doing this in this coordinate because it doesn't really matter, right? When testing the program, in fact, I was starting at 1,000, just because the area is the same no matter where the thing exists on the plane. And if you think about it this way, without it being on the origin, all the multiplications by 0 go away and you really have to get your things right.
Yeah, that's what. Yeah, cool. That makes sense. So I don't understand why you've added everything. So is this, where are we at this point?
Now,
so when you get,
I'm just going down. I started here and I'm going down. Actually, the drawing will start here, but I'm starting the explanation here because that's what makes most sense to me. So we started here, we are going right, and then we are
don't do anything about going right, and then now that we're going down, we add everything on the x.
To the left, yes. Okay. Now we go to the left, if you remember the original drawing behind my red rectangle. So we go to the left, we don't do anything, and then we are going down. So again, we will add all of these tiles. And now we go to the right, we don't do anything, and now we are going down. So we add all these tiles. And then we are going left, and we arrive here, and then we are going up. And when going up, we are going to snip, snip, snip. So we are going to snip everything to our left when we are going up. So we are going to snip these guys out. This is subtraction. And then we got back to the origin. So how do we cover these other tiles? Well, when going to the right, you will, so it started here. When going to the right, we add distance. Oh, this is still the eraser. You add distance. So you cover these tiles. Just no multiplication, just area plus equals distance. So if I started here and I went to the right for 3 steps, plus 3. Then going down, going left, going down. And I'm going to the right, plus distance. So I went to the right by 1 step, dot. And then when going up, snip, 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 snip. And then you are left with this guy. Okay, so that's a special case, plus 1 in the end. And then you cover the whole area. Now, let's see what the code looks like for this. Because
That's very nice.
it is very simple indeed. So,
Wow.
when going to the right, you are going to plus distance, like I said. So these are the blue tiles, and if I put them side by side, will it work? Yes, it will. So when going to the right, plus distance, the blue tiles. When going down, coordinate x plus 1, that's to make sure that you're counting the right edge, times distance. So you cover all the tiles to your left, including these ones. When going
Yx
left,
plus 1?
huh?
Yx plus 1?
Oh, because you want to count the tiles here on the right. It's just
Inclusive.
yeah, you want it to be inclusive. When you're going to the left, don't do anything. Area plus equals 0. I put it here just for completeness. And when you're going up, then take your coordinate times distance and subtract. So that's when I put my eraser tool and I erased all these dots. And to begin with, area equals 1 to account for this fellow. And that's that.
That's very nice. Do you have any way of visualizing what you're counting?
No, console log area.
That's very cool.
But there are some more things that stood out as I was doing this. So we thought that perhaps, and I have a list, we thought that perhaps clockwise motion versus counterclockwise motion would matter. It does not. I tried all sorts of boards with counterclockwise motion, clockwise motion, and I put it, so it doesn't really matter. The algorithm just works in the way that I explained. Also, we thought that perhaps we would have issues if we were on the left of the number line, so we were dealing with negative coordinates. Not an issue either. The algorithm that I just explained works just as well in whatever quadrant of the Cartesian plane you put the figure. Doesn't matter.
Wow.
You don't even have to start at the origin, like I said. You can just translate this figure, move it around the Cartesian plane anywhere you want. Doesn't really matter. So in my code, I have x equals 0, y equals 0. Just put whatever numbers you want here, and the thing will work equally well.
Brilliant.
And another interesting thing is that we are only interested in the x coordinate in this case. If you look at coordinate y, we are setting it, but we are never reading it. It doesn't really matter, because what we are interested in the y-axis is the distances that we travel. So we are computing here with the distances, but never with the y-coordinates. So if you wanted to simplify this further, you could, or after I finished working on the problem, I went to the Reddit to learn more about it, the subreddit for the advent of code, and I learned a couple more things. The best implementation, according to the ranking in Reddit, was an implementation, at least when I checked it.
Do you want to? Yeah.
It was an implementation in Python that did exactly this. Perhaps a bit more clever, but it did the Green's theorem implementation. And as far as I could tell from everything I read, it was the only other implementation using Green's theorem.
Oh.
Quite interesting, right? So there is just...
How did everyone else do it?
I'll tell you. But there is one interesting quirk about the way that people implement Green's theorem, which I think is something to know for next time. Green's theorem comes from mathematics, and it comes from doing integrals. So here we did the logic of when you're going down and when you're going up. But mathematicians prefer to think of not the area to the left of the figure, which is what we ended up doing because we ended up covering these tiles, right? And then removing them. But mathematicians tend to not like this. They prefer to think about the area under the curve. So they prefer to think about this area and then removing it, which, as you probably will realize, is equivalent. So what mathematicians tend to do is when going to the right, add everything to the bottom of the figure. When going to the left, subtract everything from the bottom of the figure and deal with the vertical lines as edge cases. Just a shift in orientation that will make things more familiar for people who already know the Green's theorem. And
very nice. Well, hopefully I'll get an opportunity to implement Green's theorem in one of the future problems.
Yeah.
Now that I have a lot of faith in it, it's very cool. It's amazingly like efficient and useful, right? But you were gonna say, how did everyone else do it?
Yeah, so there are like one or two other people who came up with these slicing strategies that essentially is what we are doing, but they sliced things in different ways. So they sliced like rectangles that overlap. So they slice, for instance, this would be a slice when you're going down. And then when you're going down again, you're actually here, right? If you think of the original figure that I drew, you would be here going down. So they...
Quite like this pixel art for visualizing this kind of thing.
Yeah, it's neat, right?
Yeah.
It's kind of clunky with the trackpad, but it is neat. Yeah, it is clunky with the touchpad. But what they do is, so we are here and we are going down. So they drew,
just as I said, it was good.
They draw this, but then you counted these 3 tiles twice. So they came up with ways of detecting overlaps to subtract. So there are even visualizations on Reddit for this idea. And that's kind of neat as well. But that's not what most people used. Most people use this thing called the shoelace formula. And then something...
That's what somebody rocked up and said, do the shoelace algorithm.
Yes, someone in the chat said use shoelace. And we would have if only we knew what it was. And the shoelace was actually the Python snippet that we found online, where it's mixing coordinates of the x and y axis in the time axis, in the temporal domain. Yeah, so that's the shoelace algorithm. And then to cap things off, you first use the shoelace formula and then Peake's theorem.
So how does shoelace algorithm, like, why does it work?
I have no idea because I didn't spend the time to understand it.
Okay.
Yeah, after the stream, I was like, oh no, I want to figure out this off by once. It's killing me. So I went and I finished this, and then I skimmed the Reddit, and I was like, okay, I'm done for the day. So I didn't understand shoelace's formula or Peake's theorem.
Should we have a quick look now?
How about we don't? Just
put
it on the queue of things to learn later. Because and there was even one other, and everyone used that. And I read some of I skimmed over some of the code for people who did the shoelace, and I think that my implementation with this idea of Green's theorem is much simpler to conceptualize. But well, it is what it is. If you already know.
Until we understand the shoelace one, and then maybe we would change our minds, but I'm not sure. I guess it does something very similar, though. Like, it does do these squares.
I think it's actually doing with triangles. I think it's covering the figure with triangles. And that's why you need to later use Peake's theorem, because with the triangles, you're computing the whole area, and then you need to compute how many... I guess what I'm trying to say is, with shoelace's formula, as far as I understand, you're computing triangles, so you get the area in, like, the real domain, the continuous domain, and then you want to use Peake's theorem to discretize it and go into an integers domain.
Interesting.
That's what I understood from the scheming that I did. So there was one
So
person
from
who implemented your idea, which is this person,
the
the
zooming,
zooming. And the way that they do it is that we thought about using maybe the smallest number or the GCD, the smallest distance, or the GCD of the distances. And that doesn't work out well because with the smallest, you would end up with
floating point fractions.
fractions. And I guess you could round things. And if you do the GCD, then the GCD was 1. But what they do is they don't scale the whole figure with one zoom factor. What they do is they get every x coordinate that will appear on the path and every y coordinate that will appear on the path, and then they do like a fold. So here you can see that I folded 2 regions that have different amounts of lines of code. So this region is just 3 lines. This region is much longer. But they take the same amount of space on my screen, right? That's kind of the idea. As long as you have every x coordinate and every y coordinate that will appear in the final problem, then you can contract things in this way and then do even a flood filling algorithm. Doesn't really matter. But then to expand things out, you have to remember the zoom factor of each region independently. So if this region was colored, you have to multiply by 3. If this region was colored, you would have to multiply by a bigger number. And you have to keep track of everything. And then you can do the contraction. The problem becomes tractable. And you do the expansion. So the trick is
Sounds
variable
complicated.
zoom factor.
So but doesn't it depend on remembering the zoom factor for every like rectangle?
Yes.
And then like working out, multiplying the area by that zoom factor for the rectangle, which is like it's a bit of mind-boggling to keep track of.
Yeah. It's not that difficult either. You can just do it in one axis, like the y-axis that I'm doing here, and then you have to keep a list of numbers that you have to multiply by in the end. So of course, working out all the edge cases, complicated. Plenty of off-by-one mistakes to make here. But it is a viable strategy as long as you use a variable zoom factor, which I thought was cool. I thought it would be amusing because you wanted to use the zooming strategy.
Yeah. That would have been cool. Nice.
Now, what really got me thinking yesterday was what would happen if the path intersected with itself? What would happen? How would we change the algorithm if we had to draw a path that was like that, just going over itself over and over? It doesn't really matter, right? In the end, there is a convex shape and you need to fill it in and count the number of squares. How would we do that? That is an interesting twist to the problem.
And Green's theorem wouldn't do that. It would always calculate the inside, but not the whole thing.
I think then I didn't test, but using Green's theorem, I think that if you have a shape that intersects with itself like this, you should be good. But if you had a shape that intersects with itself in like the wrong direction, I think it would not count this as interior because of the parity. There is an even odd situation. Even using SVGs and probably Illustrator, I'm sure Inkscape has that. You have this even odd rule that will fill this in or not. And I think that this even odd rule would mess up my implementation of Green's theorem.
Interesting.
So that's an interesting problem to think about. Luckily, the inputs didn't have any of that, but here's a mind bender.
Yeah, something for day 24.
And a last note that I have here is that I asked about this on the stream, like, how can I tell? And of course, in the end, the direction, clockwise versus anti-clockwise or counterclockwise, didn't matter. But if it did, how can we detect that we did something clockwise versus counterclockwise? And I am drawing one while saying the other. But how would you detect that this is the case? And I had an insight. I think that the way to do it is to just count the number of turns. If you did more left turns than right, you did counterclockwise. And if you did more right turns than left, then you did clockwise. I think that's the trick.
That would work. That seems like it would work.
Yeah.
Because it's very discrete, isn't it? You can only go up, down, left, right.
Yeah, and even if it wasn't, we would always be able to argue that if you're doing a curve to the right, more so than you do a curve to the left, then you're going clockwise.
You could do many tiny curves to the left, but not have a very steep angle. But because all the change and turns are the same, like it's about the...
Yeah, you would need to not compute with simply left turns, but the amount of degrees of the left turn.
Yeah. I mean, that's one way. I feel like there's might be a more elegant way, but maybe that is the way.
Yeah. All right. So with all of that said, I have shared all my insights about day 18.
Yeah, it's a lot of insights.
We have collected our star for day 18, and
nice.
We have a new animation.
Mm.
So let's go to day 19.
Let's do it.
Aplenty. The elves of Gear Island are thankful for your help and send you on your way. They even have a hand glider that someone stole from Desert Island. I don't remember the... yeah. Okay. We had this in the past. And that was the triangulation problem that was very straightforward. The plus-minus situation on the left. I remember that. Since you are already going in that direction, it would help them a lot if you would use it to get down there and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming a formidable heap. Heaps are gonna come in handy now. Don't worry though, a group of elves is already here organizing the parts and they have a system. To start, each part is rated in each of 4 categories. Extremely cool looking, musical, it makes a noise when you hit it, aerodynamic, and shiny. Christmas! Then, each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and contains a list of rules. So now we have multiple workflows containing rules. Each rule specifies a condition and where to send the part if the condition is true. The first rule that matches the part being considered is applied immediately, so we will do some short circuiting. And the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. So I'm thinking of like a switch case block with breaks in every case and a default clause in the end. Consider the workflow EX, open curly braces, X greater than 10, 1, or if M is less than 20, 2, and if A is greater than 30, R, otherwise A. This workflow is named X and contains 4 rules. If workflow X were considering a specific part, it would perform the following steps in order. So it is more than 10, extremely cool looking. Then send the part to the workflow called 1. Rule, if it's less than 20, musical, go to the workflow named 2. If it is if it's greater than 30, aerodynamic, go to no, don't go anywhere. It has been rejected. The part has been rejected. And rule A, Otherwise, because no other rules match the part is immediately accepted.
So I don't fully understand. What's EX
That's the name of
stand
a
for?
function.
And we're parsing this function.
Yeah, so this is the name of the function. This is the body of the function. The body of the function is a switch case.
Okay.
If this rule applies, then call function 1. If this rule
Yep.
applies, call function 2. If this rule applies, then return false. If this rule applies, return true.
Yep. Okay.
If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. If a part is accepted, sent to A, or rejected, the part immediately stops any further processing. The system works, but it's not keeping up with the torrent of weird metal shapes. The elves ask if you can help sort a few parts and give you the list of workflows and some part ratings. Your puzzle input. So this is the program, and this is the data that we are going to flow through the program. The workflows are listed first, followed by a blank line. Then the ratings of the parts the elves would like to sort. All parts begin in the workflow named in, which is this. In this example, the 5 listed parts go through the following workflows, and they are careful to always give us rating for all the 4 attributes in the same order, which is convenient. And then we will work on this when we start implementing and looking at examples. Ultimately, 3 parts are accepted, adding up the A, M, A, and S rating for each of the accepted parts gives this number. For the part with X, blah. Blah, 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 for the part with X, blah, blah, blah. And then we are adding all the attributes of the accepted parts. So our job is to flow each of the parts through the program, filter for the ones that were accepted, and add these attributes together for all of them.
Add all of the attributes together.
For all the accepted parts. Sort through all the parts you've been given. What do you get if you add together all the rating numbers for all the parts that ultimately get accepted? And let's take a look at the puzzle input to see if it's manageable. There is lots of instructions, not so many parts.
I'm not sure I fully understand the problem. So it goes, you need to count which how many functions it succeeds for?
No. Your job is to just take one of the parts and start at in. So, for instance, let's take this part. Does it have shininess less than 1351? This first part has a shininess of 2000. So, no, this is not the case. It's not less than. So, go to the other one. The other one says, go to QQZ. So, we are going to QQZ. Is the shininess greater than this number? As a matter of fact, it is. So go to QS. Now let's find QS.
Got it.
Is a shininess greater than this number? It's not. So let's go to L and X. Is the musicness, the musicality, greater than this? It is. So accept. So we accepted this part, and it is then going to count toward the max, the sum in the end.
So sum up all its parts, and then, okay, cool.
Cool?
Yep, got it. It should be relatively easy, this part.
Yeah.
A bit fiddly, but
Parsing
okay.
Parsing is probably a bit tricky, but other than that, it's not terrible. So.
Yeah, but you know how to use regex. I've seen you before.
Yeah, and this language is regular enough because it doesn't have any parts that expand. So.
Could you send me a VS Code link if you haven't already?
I have not. I forgot about that part.
Oh, it's lovely and raining outside. So nice to be inside.
Well, over here it's sunny.
Well, yeah. There's always somebody who's got it better. All right.
So we will have two parts. One is the, do you want to call this the program and the data?
Um, yeah, I like that. It's kind of a graph, isn't it?
Yeah, you can also think of this as conditions to follow nodes in a graph.
Yeah, yeah, that makes sense to me. Or maybe a program is a nicer way of thinking about it.
And let's perhaps use the terminology that they use, workflows.
Mm.
And these are the parts, right?
Well, I don't know. I think it could be cool to make this a bit of an exercise in compiler type things. Abstract syntax tree. And yeah, function calls. I don't know if that's an interesting abstraction for you to explore.
You wanna play something, you wanna go with a wacky approach?
Yeah.
This is valid JSON. Well, not quite because of the lack of quotes and because of the equal sign, but we can easily massage this into JSON. And we could write some clever snippets that turn this into a JavaScript function, and then we eval this.
We could eval this.
Do you wanna
Yeah.
do that, or do you wanna go with a more principled approach of parsing and stuff?
I kind of want to do the parsing one.
Okay. So for my workflows, no, for my parts string, because that part is easier. So my parts are my parts string split at new lines, and I will trim stuff in the beginning because I don't want to deal with this new line at the end and this new line in the beginning. So this is going to be one of my part string, which I'm going to map. And then I will have one of these strings, and I will parse by saying part string match, and then I will have a bunch of named groups in the end. And my regular expression is going to start at the start of the line and at the end of the line. I will have an open bracket and a close brace or bracket? Brace, I think.
Do you need to get rid of any? Oh no, okay.
Then I will have x equals, and I will want to capture this with the name x, and what it is a bunch of digits. Then I will have comma, and then I will have.
Is it the same format for the real input? Yes, it is. Okay. Just in case there are some other variables.
Yeah, they're always specifying all 4 attributes, always in the same order, so it's easy enough. So 1, 2, 3, 4. There. Let's see if we got things right. Yeah. Oh, and it would be handy if we converted this into numbers. So let's do that. No, that's not how it goes. It is this. Maybe I should do it here, right? Yeah.
Yeah.
I'll do it there.
You could do like entries and then object from entries. Yeah, that's what I was thinking. I don't use groups enough in regex. I think it's really nice. But how do you go about like
There.
making sure your regexes are rock solid and testing them? I guess just unit test like anything else.
Yeah, just like this. I'm doing it right now.
Yeah.
Put a bunch of examples in, see if they work out.
Mhm.
And they do. So we have done the parsing of the parts. Now let's do the parsing of the workflows, which is slightly trickier. So again, I will take my workflows string and split at the new lines. I will map the workflow string and I will have one regular expression, but in this case I think I will need a block because there will be multiple things going on here. So I will have a regular expression that is going to start at the start and end at the end of this string. I will have a bunch of letters and they don't have any capitals, any of that, so it's easy enough to just say this. I will have multiple of them, so this I'm matching this part.
Mhm.
Then I will have a literal set of braces, and inside I will have what I will call my instructions, right? That's what they call it. Rules, they call it rules. So I have my rules inside. And my rules are gonna be pretty much anything for this time. I will elaborate on them later. So here is a group that I'm calling the rule name.
That makes sense.
No, the workflow name. It's the workflow name. But what exactly do they call it? It's named X. So okay, name, or maybe even name. No, workflow name. In these are the workflow rules string.
Interesting that you're not trying to parse them outright.
I'm not trying to parse them outright because there will be multiple of them, and I think it would be easier to just take this string and split on the comma.
I mean, yeah, definitely. But I was expecting more from you, Leandro.
Do you want to do this in a single regular expression? I understand.
I would be very impressed if you can. You'll get some impressed points. I think you did have a strategy for doing it in another Advent of Code where you had this like comma thing. I guess it's like,
I'll start with the match that I have here and I will experiment with it. Because it maybe is possible, yeah? Doesn't hurt to try. So far our strategy is working out, but we want to elaborate on this middle part. So here we could split on the commas to begin with. So we will have a first rule And then we will have comma and a second rule 0 or more times. And we already don't match. No, we do, because we are looking at the groups. So I should name one of these groups at some point, but for the time being, we are still capturing stuff and we are fine capturing stuff there. So as long as it's matching, I'll believe that I'm doing in the right track. So now we need to look into these guys. And what we have in them is one of the attributes so either one of these letters followed by either greater than or less than, and never less than or equal. They don't do that, right? Followed by numbers. All of this, or, and I'm going to put parentheses here because we have been beaten by that in the past, or we have an accept or we have a reject.
Yeah, we also have the colon part of things, don't we?
Ah, right. So that is just... I got it wrong. I understood it wrong. So I am removing some parentheses and let's see. So here I have the Christmas part, S, A, and so on. Then less than or greater than, a bunch of digits, column, and then A
and then a name.
C plus.
Well, it could be accept or reject, couldn't it?
But that's... okay, yeah, right. Accept or reject. Or, actually, I will write it like this. Because I don't want to have multiple capital A's. Okay. If I did all this right, then it's still gonna match. And it does.
And the first part is optional as well. Like you can just have reject.
Yeah, so I don't think that the first rule can be simply reject. I don't think that there is any clause that starts with just reject. If you go there, you always reject. I think that there is always a clause in the beginning. But, okay, let's suppose that it could be the case that I don't have all of this stuff. It could be the case that I have simply an accept or reject right away. And I'm still matching. Now, the next step is that I'm going to take all of these shenanigans and I'm going to put them here. And I'm still matching. Now it's a matter of naming these groups and hoping for the best, because the reason why I didn't want to do this in the first place is that I think that the match groups will not necessarily return all these repeats.
Yeah.
But
I don't know how that's going to work.
Let's see. So let's just try and return a rule. And it comes off. And then the rest
should be
of
returning
the rules,
multiple though.
This is the rest of the rules. And you see, that's the part, well, I guess I am using an example that, yeah, that's the part that breaks down, because we have multiple rest of rules, and I don't know how to make this group return multiple of them. So the problem is that I have a capture group inside a star. And I cannot get a hold of the repeats. And that's why I didn't want to do this in one step. Maybe there is a way. I just don't know how to.
Fair enough.
But it wasn't all for nothing, because all
Um,
of these things that we wrote we will use. So I will get them from here. And store for later. But as it stands, we have a workflow name and we have a workflow rules string. So,
surely there's a way of doing this.
and I can hear you typing, so I think you're gonna tell me how to do that in a second, right?
Trying to work it out.
And while you are working that out, I will be doing it the more straightforward way, which is to take my workflow rules string, or maybe just rules string. And even my workflow name will just be name. And then my rules are going to be my rules string split at comma map rule string such that I will either I would first try to match this kind of rule. And that's when I'm going to use all this stuff that we wrote. Except that I don't need this parenthesis anymore. And I will need to name some of these groups. So let's go from the top. I will have what I'm gonna call my attribute. I will have what I'm gonna call my operation. I will have what I'm gonna call my operand. And then I'm going to have what I'm going to call my destination. Is that what they call it? Destination? Probably not. But I'll go with that. It did not match in some cases, but and then it blows up when it doesn't match. But what matters is that sometimes it matched. So let's look at the first rule in the first program. A less than 2006 P, yeah, it worked. So I'm gonna call this my comparison rule match. And if my comparison rule match is not null, return a rule of type comparison. This is abstract syntax tree for you all folks. This is a node of an abstract syntax tree. We are doing parsing here. It's real. It's real.
It's the real deal.
So it's a comparison rule match. The type is comparison. The attribute is my comparison rule match attribute. Maybe I should call this the match groups. Oh, right. No, I should not do the groups here because they could be null. So I will do that. And groups attribute, that. Then my operation. And then my operand, which I will convert into a number. And finally, my destination. And I'm not console logging anything, so let's console log the rules. Let's see. So it is a comparison.
I'm just thinking, don't you need, like, all of this can be optional and you can just be, you might just have the AR.
Oh, yeah. We are going to get there. We are going to get there. But I want to do this step by step
okay,
because
sorry.
I'm doing different kinds of rules. So that's why I have the if not null. And then I return. But we will do another one. So
Oh, okay.
we dealt with the comparison kind of rules. Now let's deal with these rules.
Yes. Can't you just make the, like, first half of it optional, and then if, like, you've only got destination, all the others are null, then you can infer the type? I guess it's nicer to have it more explicit matching, isn't it? I mean, technically it's an extra regex to do it your way, but it's also, like, fine.
You bring up a good point, yes.
Because
it is the case that all of this is optional.
yeah, but it's fine. Like, it's more. I think your way is nicer. It's more readable, right? What does that do? The question colon.
It means I want the parentheses, but I don't want this to be a captured group. I'm only interested in the parentheses because I want to put this question mark here in the end.
Ah.
So it works, David. If we have one of these full rules with a and less than and a number and a destination, we capture all that. But if we go to the third, which is here, and look at it, we don't have any of these things. We just have the destination. So good job. Yeah, you simplified the program.
A little bit. And made the regex more complicated.
And now it should always match.
Yeah.
And it does, because it doesn't blow up.
Are you going to add the type?
Not
I guess
necessary
just
anymore,
if
because there is a single node type in our tree, and the type is determined by the undefineds here.
Yeah. Cool.
Ooh. Good job, David. So now we have all of these. All we gotta do is return.
By the way, I don't know if it's still a performance consideration, but, like, I think it used to be that, like, defining the regexes like as a constant rather than redefining them every time has quite a big impact on performance. But also the regexes, like even though they look like strings, they actually have state, and like each time you use them, they like have like an index that they're tracking or consuming in the string and stuff.
Yes, in general, yes. In our case, no, because of these anchors, but in general, yes.
It's kind of tricky.
All right. We did some proper parsing.
Nice. What's that object null
It's
thing?
because I used the dot groups, and then it is explicitly saying that the prototype of this object is null, as in it doesn't have any inherited properties for those of you watching at home that care about prototype-based inheritance in JavaScript. It's a non-issue. We could just JSON stringify.
But does it have no properties?
Huh?
Does it have no properties, or is it just dominating?
It has properties. The properties that we set there are there. It's just dot groups is
cool.
acting a bit funny, and it's doing actually what you want, but because you could have an attribute name here that is one of the things that comes with the default objects in JavaScript. So here is an empty object, and it does have some methods, right? For example, has on property is a function that you can call on objects. But if this was, and what this function does, for instance, is ask if it has this attribute, right? But if you do this with the result of a regular expression, match groups, and I will put here a named capture group just for funsies, then it blows up because has on property is not available on the object returned by groups because its prototype is null. So this is effectively what you want. And with this, I could have even a match here that isn't called banana. It's called has on property, which would trip lots of things up. But, oh, and then it has a special case that it doesn't allow you to use this name. So go figure.
Wow. That's very interesting. So how do you create an object with a null prototype?
You say something like
object.create null.
Object.create and null.
Right.
Yeah. This is some hardcore JavaScript nerdery here.
Yeah.
Okay.
Cool.
Cool. So now we are going to come up with a... How about we just do this in one expression? We are going to take our parts, we are going to filter them, and then we are going to reduce them. I'm going to start with the reduce because it's easier. The reduce is just a sum and a part, and we will take the sum plus equals, or actually just plus. We don't even need this. Object dot values of the part, and reduce that with a plus b. And for the time being, I will take the part and I will just return true. And with this program, we should see something. Cannot find module. I am in the wrong folder. We see something. Great. So now all we gotta do is figure this part out. So we will need to run the part through the workflows. So we are going to start in workflow in, and we are going to wait a second, my workflows, they have names. And they turn into a list. I will print this out to make my statement clearer. So I have a list of objects with names, but the names are guaranteed to be unique. So this is actually an object. So what I'm going to do is return this, and then object from entries that. And now my workflows are indexable very easily. Good stuff. So I will take each of the rules of my workflows at workflow, and if my rule is equal to accept, then I am going to return true, because it needs to be one of the parts that add to the sum. Else, if...
Could we get cycles?
Let's hope not, David. If that, then return false. Else, if the rule is...
Is that how it's going to be? Isn't each rule going to be like an object rather than just a string like that?
What? Can you say that again?
Each rule in the workflow, isn't it going to be like an object rather than just a plain string?
Yes, you are right. And what I want is for this if to be here, encompassing that. It means that if my rule attribute is undefined, it have one of those cases that I have to go to the destination immediately. So I will say that my workflow.
Is that right?
That is right, thanks.
Oops. Sorry.
Then my workflow is now my destination. And I'll have to keep going. So I'll do a while through around this. And I will also break out of this loop because I have seen all the rules that I need to determine what to do next. So I will have an else block here. Well, not quite, because there's a break in the end of this block, so I don't care. So if the rule attribute is undefined, I have to do something with the destination right away, which is these things. Otherwise, I will look at the attribute, the operand, and all of that. And now my operand is strings again. What's up with that?
I guess you didn't convert them into numbers.
I did it here to the values, but I didn't do it here. Right?
Right.
Right. So...
guess you could spread it.
Or I could be explicit here, which is annoying, but I think it's the way that I like to do it, because it matches what I did elsewhere. and I will console log my workflows. And now they are not a number.
I guess that's fine.
Because when they are indeed numbers, they are correct numbers. But I could also be neat and say,
yeah.
better. Now, we are here where we have dealt with all these rules and we have to deal with that kind of rule. So I will look at my part at attribute, and I will check if my operation Abby's telling me that it's hard to hear my voice on the stream. Why would that be? Over here the volume is
I can hear you
fine.
very well.
And fair enough, fair enough. Thanks for saying that. So here, I'm using a different microphone now. Let's see if that's better. And thanks for watching, Abby.
I think for me, I prefer the headphone microphone, but I guess Abby can tell us what it sounds like.
I see that the meters are going higher now, so it should be easier to hear me. It should be louder at least. So I'm taking the part, I'm taking its attribute. Now I need to do the operation. So what I'm gonna do is, thank you, if my rule operation is greater than my rule operand. And or less than, then I am going to set my destination. Actually, I'm gonna do this, right?
Yeah, that's done it correctly now. The parens that you needed. It inserted these, operator precedents. It's inserted these two.
Yeah,
here.
These are optional because of the precedence of these operators, but it's nice that Prettier is putting that in place for me. But it's optional because and will happen first and or will happen later, because if you put no parentheses, then you want the order of operations to be what is called, do you want a fancy term? It's called the disjunctive normal form, I think. Or conjunctive normal form. One of the two, but I think it's the disjunctive one. Okay, so my rule is not defined.
Yeah, it needs to go inside the for loop, I guess.
What needs to go inside the for loop?
Like, don't you need this? Doesn't this need braces?
Yeah, thanks. Oops. There. So I don't need to console log the workflows anymore. And I have 19, 114. 19, 114.
What happens if you get to the end? What What happens if you get to the end and nothing matched? This should like fail, right?
Yeah, because it was not supposed to go in there. But not for the rules. You want this one out. And not even here. No, the error condition is if nothing matches, you will be in this while true forever.
Yeah.
And that is if there is a cycle. Because, no, if there... Yes, you will get into the while true if there is a cycle. And if nothing matches, you will get in a cycle because you'll never update the workflow. You will just keep trying the same workflow over and over in a cycle.
Yeah, so that we should handle that case, right? Or at least we should throw an error for now.
No, an infinite cycle means the program doesn't terminate. But we already seen that, at least for the example inputs, there are no cycles. But if the program doesn't terminate, we know that it's because there is this problem here. Or do you want to do a whole cycle detection thing?
No. I mean, if we get to the end of the rules for any workflow, that means we haven't changed the workflow. Oh, sorry, no, we're breaking here, aren't we? Shouldn't... yeah, we need to... Yeah, okay, no, that's fine. I'm just thinking, like...
We could easily turn this into an else if you wished.
I'm just thinking, like, to distinguish between... Basically where we didn't change workflow. Is the only... But whatever, this is okay. If it's terminating, it's working, so never mind.
And I don't like how these two blocks have the same... We already have the right answer, by the way. So, hooray. But yeah. I want to nice. Refactor this before we move on, because I don't like the way that this block repeats. So there is an if and another if. So I could just say this. And then I can get rid of those braces.
Oh, very nice.
That is very satisfying.
It's a very good refactor, actually, yeah.
And everything still works. Is there anything else that I want to do about this?
Why don't you do... How about this? It's a suggestion. Could you continue the outer? And then here you could throw an error. If you got to here. Really want to throw that error, don't I?
Yeah, and I want to make you happy. So continue. Do the label as well.
That should work.
It does.
Cool.
So, let's go get our star.
Hey! Wonderful. All right, let's see if this is a tricky one for real or not.
No need to read. Even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all these workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings... Oh, we call these attributes. We should call these ratings. Can have an integer value ranging from a minimum of 1 and a maximum of 4,000. Of all possible distinct combination of ratings, your job is to figure out which ones will be accepted. In the above example, there are distinct combinations of ratings that will be accepted. Consider only your list of workflows. the list of each part ratings that the elves wanted you to sort is no longer relevant. So now we are interested in the instructions, but not on the parts anymore. How many distinct combinations of ratings will be accepted by the elves' workflows? Now, there are only 4,000 possibilities for each rating. So we could just instantiate all 4,000 of them and look at only that rating as we are going through the rules. Or we could do range arithmetic like we did on the day of the mapping seeds to soil, soil to water, water to humidity, and so on.
Mm-hmm.
How do you want to go about this? Do you want to try just passing out 4,000 of them and then multiplying each individually?
I want to go back to the eval version. No, I'm joking. That number looks really big. I don't think that we can brute force it in the way that you suggested without doing the like range arithmetic.
Oh, right, because the ratings we cannot pass them individually. They interact.
Yeah, there's the like combination of all. So what's that? 4,000 to the 4th? Is that right? So that's how many possibilities there are?
Yeah, if we could decompose the problem into each rating individually, then it would not be 4,000 to the 4th. It would be 4,000 times 4. But you are correct in observing that we cannot separate the problem in this way, because it could be the case that you need to be less than 537 and you need to be greater than. Both of these things need to happen or actually both of these things need to not happen for you to be approved.
Yeah, I'm thinking more that we could maybe flip the problem on its head and start with all the acceptance criteria as our start nodes, and then result in all the ranges which are valid for all the possible paths.
I see. So we start here at the approved, and then we go back in time and filter until we can reach the in.
Yeah, so we fork for all the possible entry requirements.
So
we sort of work our
we
way.
need to say, for instance, start as approved, and if it was the case that m was greater than this number, then we would have gone here, which happens to be approved, but never mind that. So we would have gone here. So m must be less than or equal to this number for us to have reached here. And we have been there. So now let's find everywhere where I could have arrived here and repeat the process. So now I'm putting another constraint, the constraint that s is less than blah, blah, blah. And I like the way you are thinking. And I think that if we did that, then we would have to learn how to merge sets in the end, which is not the biggest deal. We just see if the sets overlap and merge them.
Yeah, and we sort of fork these. We would have these like, I guess we would have ranges, but we would start with like infinite ranges, and then we would like start cutting it, and then when we reach fork points, we would like fork our like current range, the current ranges which are matching that node into more kind of thing.
There's one thing that I don't like about this, which is our data structure is not really amendable to that, because, for instance, when we reach here, we need to find where are all the places that I could have gone, or where have I been before I arrived here? You know what I mean? We would have to find QS. And our data structure is not amendable to that. We will need to traverse this a lot to get
We can, but we can invert
could invert,
our
yes.
data.
If we didn't have this
That seems
constraint,
reasonable.
if we didn't have this constraint, I would have liked your idea better. But because we have this constraint, I think that going forwards is easier. Just in terms of like the
What
details of the
constraint?
implementation. The constraint that we have arranged to begin with.
Well, you think that makes it easier?
Well, it makes it easier in the sense that when dealing with infinities, things would get tricky, and your way would not deal with infinities, I think. Or maybe it even would.
No, we would start with. I guess we would start with like 1 to 4,000 on every, like, as ranges 1 to 4,000 on all of them. On as our start node would be like start at A with the state of 1 to 4,000. If you
Well, you are starting by assuming something that is not true, right?
until it's like, okay, well, that half of the range can no longer be used, so we're going to chop it up and then fork it into this possibility and that possibility.
But you started by saying, assume that you are in an accepting node and that your
Yeah.
ratings are 1 to 4,000 for each of them. So I see two problems in this. The first is that ratings going from 1 to 4,000 in each of them is in the order of trillions.
But that's fine. We're still working with range intervals, right?
Okay. So you're still working with range intervals, and you're starting by assuming something that is false. For instance, you would assume that rating 1111 is accepting, while it isn't.
Yeah. So I would assume that we're accepting and that like x is like 1 to 4,000. So like S1 and 4,000. And then the same for all the others. And then, like, as soon as we have a criteria which doesn't match, we sort of change this to 1,000. And then, like, you see what I mean? We start manipulating this to create new nodes which are valid as we traverse our way down the tree.
Mm-hmm.
That's the general idea.
What is the advantage of going from A to in instead of in to A?
That's true, actually. What is the advantage?
I see two disadvantages from doing it from A to in. The first is that we have a data structure that is not really amenable to that, but that's easy to fix. But the second is that we have many A's, so we have many starting points. And we are shooting in the dark and trying to hit in. And it could be the case that one of these A's or many of these A's are not even reachable under any conditions. They're just unreachable nodes. And we would do some work to prove that. While if we're doing it in the from in to A order, we are guaranteed to every time we find an A or every time we find an R, we did some productive work.
Yeah. Well, yeah. That makes sense. Yeah, I guess it is just the same as starting from in.
Okay. So let us get our inputs back, and or maybe let's create a copy of this file, which still works. And in this new file, let's uncomment this. Let's get rid of all the parts parsing and even all of this work. Well, not all of it. I still like some of that. I still like this function. And I want to hold on to it. But Even this parts string we don't need anymore. Now, I guess we are going to do this in two parts. First, we are going to start at in and do all the filtering necessary to get to all the accepting nodes. And we are going to accumulate all the input ranges that got us there. Second part, we are going to merge these ranges because there could be different ways of getting to an accepting node that overlap. And then we are going to do the simple part, which is to just multiply them. So let's start by computing the ranges that are valid. This is a tricky problem. This is like just very well designed because it's tricky in a way that I like, that makes sense to me.
Okay.
So
I'd like to see you design some problems, actually. That might be fun.
So we will have what I'm going to call my ranges. And it's going to be a set. Might as well just be a list. Then I am going to have a notion of states that I need to work on. And to begin with, my initial state is going to be in which workflow I am, and my range, which to begin with is going to be start at 1000 and at 4001, because we learned that non-inclusive ranges are nice for this kind of interval arithmetic that we are getting ourselves into. And I think that's all I need for my stage. And I will also have over here my visited workflows, because it doesn't make sense to go in cycles.
But there are no cycles. Didn't we verify that?
Well, we verified for the given parts in part 1 there are no cycles, but now we're dealing with every possible part. So there could be cycles. But my claim is, and let's see if I can convince myself and you that this is true, that if you go in a cycle with any particular given part, if you go in a cycle, it means that you will keep going in the cycle. Because whatever was true of any given part that made you go to QS will be true when you go to QS again. So there should be no cycles. So my visited workflows is going to be a set that starts empty, and I will be accumulating workflows in that set, and if I see one that I have already seen, I bail out. While there are states for me to work on, I will get a state. I will go over the rules of the workflow that I'm in. And I will start filtering ranges and accumulating more states.
Yeah.
So this is going to be a for loop. So if my rule rating, the rule rating being this, for instance, is undefined, it means that I have one of these unconditional rules.
Yeah.
So I will add to my list of states a state that reads: the workflow that you are going to is my rule destination. For instance, this.
It's kind of just the function you have below. It's not too dissimilar.
Correct. And I'm looking at it as I implement this.
Yeah.
Yeah. So my range doesn't change. No, it's my state. My state range.
You need to add the visited workflow.
The visited workflows
If I may, I think it should be on this line. Oh no, you're yeah, I think it should be on this line, the definition of the
I agree.
yeah, okay.
I agree. All right. Let's reread this. While I still have work to do, pop the stage. The visited workflows are my previous visited workflows, plus the workflow that I'm visiting now. And for each of the rules, if my rating is undefined, jump to the destination of this rule with the same range, carry the same range, and with this new set of visited workflows. I'll leave myself a to-do here, which is like bail out on
ANR,
invalid states, because I need to address that later.
Oh, okay.
Else, I will want to push the fact that I'm going in this rule, but I need to now manipulate the range.
Yep. Okay. Yep.
And my rule attribute, no, it's called the rating now, right? Yes, my rule rating maps to a start and an end. Did I get this right? Rule rating. What is a rule? Rule rating. Yes.
Yeah.
And there are many cases to consider here. This is where we are doing the slicing.
Yeah.
So,
you might want to push more than one node as well.
yes. Yes. It is true what you're saying. Let's do a quick drawing. There is my range. That goes like this. And there is my rule that will be like cut off here and get everything to your left. Right?
Yeah.
So what I want is for my output to be that.
Yeah, I guess you're gonna kind of have to need to like mutate state. Potentially, it would be one way of doing it, because like this portion over here, I can't really, but this portion, like it needs to be in this portion for the rest of it. So you need to like if it matches another rule, it needs to also take into account that it's not matching this rule.
Yeah, to do the fall through cases.
Exactly.
So what I will do is that I will have a range that will start with my state range.
Do you want to say let range?
I can do let range. And then over here, I want to use this range.
Sure.
And then over here, I will want to mutate the range. And then, and this is pretty neat, this line became equal to this line. So I could pull this up and get rid of that.
Now I don't follow. But okay, let's keep going, because I feel like they are two different cases. Either you accept the range or you don't accept the range, and you have to create two new ranges. Either way. So I'm not sure. I mean, maybe you're thinking a few steps ahead of me, but I feel like you're going to have to create two ranges inside this for loop. We'll see.
Yeah, we'll see. So if my rule rating is not undefined and rule has rating, okay, if my rule rating is not undefined, then I will be able to use it in here. Excellent. And I will want to do this. And I will want to do that. And over here, I will want to do this. So see, David, I will be creating two ranges, one of which will fall through to the next states and one of which is not going to fall through, and it's special. So this is the case in which we comply.
Mm-hmm.
And this is the case in which we don't.
Got it.
And there is something else that I need to write here. I need to write continue.
Will you hold on 1 second? I've got to let somebody in. Back in a sec.
Pretty nice. Yes, I agree with what I just wrote. It was great that David caught the problem of the fall throughs of the ranges. That was very smart. So now we need to do the slicing of the ranges. There are two kinds of rules. Rules that say less than, rules that say greater than. And there are many places where our rules could fall into the range. It could fall all the way to the left, and in that case our output is nothing. Hello. There is the case in which it falls in the middle. There is the case in which it falls to the right. So David, just to catch you up, I was complimenting you
there are
on...
3 cases.
Huh?
No, sorry, go on.
Yeah, I was complimenting you on finding this situation of the ranges needing to fall through, because I like the way that this code reads.
I don't know if I can take all the credit, but...
And now I'm
Thanks.
working through all the cases to do the range arithmetic. So looking at the ranges that say less than, right? Because ranges could also say greater than. We are going to deal with them in a second. But ranges that say less than could fall to the left of the start, in the middle, or even to the right of the end. Like that. So how about when we have a less than, we keep the start where it is and we say the end is now the new edge. This way, we would end up with an interval that starts here and ends there, which of course is invalid. If this is the start and this is the end, this is an invalid range, and we'll be able to tell that. So I think that to slice a range, all we gotta do is take our state range start, keep it where it is, and for the new end, we take the rule operand. Now, naturally, here I'm dealing with the case of a rule operator. Do you call it operation? I called it operation. Okay, I'll keep it. Operation of less than.
This is when TypeScript is useful, isn't it?
Yeah. Otherwise,
This looks like you're writing regex. Are you doing a ternary?
I'm doing a ternary.
Oh, okay, got it.
So if my operation is less than, then I'm gonna slice the situation this way. And if my operator is greater than, then I'm gonna slice the thing this way.
It should be end.
Thanks. So, with that in mind, that's the case in which I followed the rule. Now I will take this same logic and put it here for the else case. There. Which goes like this. Now let's deal with all the off by ones that we will run into. This is the case in which I will follow the rule. This is the
Wait, hold on. Isn't this operate? Isn't the if it's this operation, then it must be this operation.
What?
So here you're checking. Is it this operation?
Yes.
Do this.
Correct.
Otherwise, it must be this operation.
Yeah, and then we do that.
Right. So why are we doing another case here, which is checking this?
Because this is the else case. Okay, let's take it from the top. The idea here is that we are in a given workflow following a set of rules, or a list of rules, not a set. We are following the list of rules.
I see.
So if we can comply to the rule, we will get here. So we are doing the less than as usual. Otherwise, I need to change this range that will be used for next time.
Yes. Yeah. Sorry. Yeah.
It
doesn't apply.
It was
to
your
rule.
insight.
Yeah.
And everywhere where I have state range, I should change to range. Because I want this operation to accumulate. Now, let's deal with all the off by ones that will arise, potentially. So if I am doing this kind of slicing, where I have a less than, and I have the same start, and now the rule operand becomes the slicing point, because it is a less than and not a less than or equal, we stay with just the rule operand. Now let's deal with the case of the greater than, which is this case. So the greater than will keep the range end, which it does, and then the start should be, because it's greater than and not greater than or equal, it should be a +1 here, because we want if we slice it this way, then actually what we want is that.
100%.
Yikes. And I suppose that if I did everything right, then I should be able to copy and paste this.
Yeah, we could think it through like we did before as well. Or we could just trust it. It's hard to think about it through.
Yeah, I want to say that it's going to work out, because we are just flipping this. So this seems independent of everything else. So I think this is going to work out. So now we will have a bunch of states. We need to check if a state is valid, if we should be exploring that state. And there are many conditions that apply here. Oh, and there's another to do, which is to deal with the accepting and and rejection cases.
Termination states, yeah.
Which I guess we are going to do all here. So if my state dot workflow is accept, then I will want to take my range and put it in the ranges.
Yep. And continue.
And if my workflow is R, then just continue.
Yep.
Then, if my workflow exists in the state visited workflows, continue. Right, I agree with that. And now let's check that the ranges are valid. We should check that the ranges are valid above, because I don't want to accept an invalid range. So maybe I could just do this.
Yep.
Or it is the case that if I take the object values of my state range and sum, so one of these.
Leandro, your audio is very low and muffly sounding at
Oh.
10:10. No, but that was 10. That was at 10:10, so that was probably the same complaint Abby was having, or maybe she would sort that comment.
Yeah, I need to remember to always switch to this microphone or do something about the levels of the other microphone. So I have a range, and if it is the case that some of the ranges has a range end that is less than the range start, then I will want to continue. I want to bail out.
Yeah.
And do I have enough by one here? What happens if the range end is equal to the same to the start? I also want to bail out because an interval of start and end of 1 is invalid because and is non-inclusive. So I want this.
Yes.
So I have dealt with the case of rejection and acceptance.
I feel like you're an off by one specialist.
I have a case of detecting cycles. I have the case of invalid ranges. And I have, I think, everything I need. So let's see what we get as ranges after all this is said and done. Well, visited workflows is not a function. Where is this? It's has.
This.
And now we have ranges.
Now we need to just count them up, I guess.
There are some undefined here, so that's no good. The rule operand have many undefineds indeed.
I'm not
This is
seeing
you're gonna say that I need TypeScript, right?
it. Yeah. Just rename to MTS. Nah, but you'll also need to like define the types. But that's cool. You can define the types quite easily. Just like in the parsing code
State
above, you
is
just do like
possibly
as.
undefined. Ah. Oh, shucks.
Yeah. Why is it failing? Like, why can't it understand regex? I guess it doesn't know the workflow string is a string or something. It could be undefined. But it doesn't know about the rules, does it? You need to do like at, just like as.
Okay. It was simply a matter of this could not match.
Yeah, does it know the names of those things though? What is the type of the resulting workflows? Does it know?
That's cool.
Yeah. Huh. Impressive. Okay,
And
cool.
the
So now
operand
they're
could
in
be
type errors.
null, but the rating, operation, and destination cannot. That's not quite true, but that's all right by me. Because we know for a fact that this could be undefined.
I guess you could do like this. And then it would be like, yeah. Well, no, you probably want this. Because empty string.
No.
But
It's not
actually
an
it's
empty
gonna
string, it is undefined. And it doesn't help with the type.
but if it's the or undefined, it will help with type, I reckon. Yeah.
I don't get it.
Well, because it's because before it was string, right?
No. It was string or undefined. Oh, okay. No, the type was string. I get it. Okay, continue.
Yeah, and if you do, this, but on an empty string, then it could be undefined. So we've now changed this type from being just string to string or undefined by like.
Well, this TypeScript thought would always be the case.
Yeah, it knows that a string. If there's a string, it's not gonna. Yeah. Yeah, and the nice thing about this as well is that you can always index, because like it will always be populated, so you're not going to get any type errors by like trying to use dot rating. But we still got a lot of errors.
When we pop, it could be undefined because here we have said that the length is greater than 0, but it doesn't know that. Yeah, I like to avoid exclamation marks when I can. I know that I put a bunch of them above, but
I guess you could do just like if not state throw. I normally use like an assert function for that rather than if, but yeah.
Fair enough. Fair enough. Now, it doesn't like the fact that I'm putting state.range.
Oh, you haven't defined here. This is like.
No. Is it?
Yeah, yeah. It's like this, something like that you need.
Okay. Then, here is the matter. Here is where we are really having a problem. Why? Property start does not exist in X blah blah blah.
Oh, because you've got multiple ranges. You need to index out the range, like from the
rule dot upper
rating.
Yes, rule rating.
Yeah, I'll leave you to do the others.
And it does not like this because it could be undefined. But it isn't because of this. But I will do the same thing again now. there are three things: the rating, the operation, and operand.
Yeah.
And now it doesn't like that. A computed property must be of the type string, number, symbol, or any. And what is
Isn't it and?
Yes. No type errors anymore.
Although, yeah, cool.
So now all we gotta do is run this TypeScript. Do you prefer to compile it to JavaScript and run it in Node, or use something like Deno?
I prefer to use TSM.
TSM?
Yeah.
Never heard of the guy.
It's just like it hooks into the require bootloader thing, and I believe it uses ESLint, or it's just like way faster than TSE and allows you to like run things. I'll send you the link, and it's like I strongly recommend it.
I used these things in the past. I used TS Node, for instance. These things always...
TS Node is very slow.
Yeah, no, the problem I have with these tools is that they are hackish and they always end up breaking, and they don't use the TypeScript compiler, so what is the point in doing all this type work and not using it? So I'm going to install TypeScript.
Does it use the TypeScript compiler?
And not only I will install TypeScript, but I will also install my radically straightforward tsconfig.
Very nice.
There. And
what does your radically straightforward tsconfig do?
I will show you. Very little. It will set most things to be strict. It will create all the files that you want to include in a build for libraries that you publish on NPM. So you want source maps, and you want the .d.ts files. I set most things to ESNext or something like that. I include libraries you would need for the browser if you want to do client-side JavaScript. And I do this, which will be necessary if you have libraries that have type errors in them, and you want to believe the type declarations. You want this if you're using ESBuild or Babel, because you don't want the modules to depend on one another in terms of types. And if you're using TypeScript compiler, it can resolve that, but ESBuild and Babel cannot. So you do lose some TypeScript features if you do this. I think you lose like open enumerations and stuff that people most often use anyway. And this is just to make ESM work.
Okay. Yeah, so by the way, TSM, it just uses ESBuild under the hood. That's all.
Okay. So that's better. But it's still hooking into the module system to do that. And that part is experimental, or at least it was until recently. Loaders. Is that the part? There used to be like a huge experimental warning. But it's
no longer there.
It's no longer there. So yeah, it seems like now it's stable. Yeah, I know. And tools using these things, they tend to break. Like Jest broke for What must have been
But
years.
these are customization hooks. These aren't necessarily the require hook.
I think it is this thing that breaks everything, and I just stopped using Jest, I stopped using TS Node, and my life has been much happier. So I'm gonna use... Oh, and I need to put stuff in the right directories, I think. I could just say this, I think. No inputs were found.
So I think the -r require is not experimental. The other hooks are, though.
But how do you compile the dependencies? So in this case, we only have one file. But if we had import another TypeScript file, it would need to compile that as part of an import hook, or whatever they call it, customization hook, right?
I guess so, but I don't think it uses the... Maybe. I'll have to check exactly how it works. But I think it... Yeah, I don't know. I think it's a flag rather than... Like, I don't think it's necessarily using that customization hook API.
And it is creating a bunch of junk here, but never mind that. What is up? We have some errors. Not only that, we have type errors. And not only that, they may be right. So let's try and go to this line. And yeah, the type errors now appear here. Probably because in my TS config now we have some more strict stuff. And do we believe this to be right?
This is this is because it might not be defined in range, I suppose.
What is rule.rating type? Rule.rating type.
Oh, it's a string. We should make it an enum.
And where does this type come from? It comes from workflows type. And
Like... That should do it. No?
well, we know this is right. Right? We know that this is right. We know that this map is okay. So we can just... Or maybe... I don't know. See, that's why I didn't want to go with TypeScript, because now I have to think of all these questions that I don't care about. But I guess it's thinking about these questions that is going to help us out, so...
I guess you could just, not only that, well, just one thing you could change, which I think would be very little...
This doesn't work, right?
Work. I think very, very little work, if I could just suggest one thing.
Go ahead, I'm following your cursor.
Yeah, sorry, I was following yours at the same time, so I didn't... If you just do, that... Ah, okay. I would have thought that would fix it. You see where I'm going? But it's saying it could be, like, undefined. Still.
Well, so
I mean,
let's do both. No, stop. We got rid of one problem.
Almost. But now we have the same problem we had before.
And why do you want to be strict about this? Why are... I don't get why TypeScript is being flex about that, but strict about this.
I mean, what you could do and then I don't know if this is. I just want to check if this works. We can undo if it doesn't. No, it doesn't. Would have thought. Yeah. Okay, fine. We should be able to work this out.
Really, our problem was this, right? Our problem was this. So how about we get back to the JavaScript version, fix it, and go from there?
Okay.
So I am deleting a bunch of things. I am npm uninstalling.
I'll do it in TypeScript tomorrow just to make our lives harder.
Okay. Let's give this program a read over, because now this is the result of the TypeScript compiler, which may or may not be what we want.
Oh, that's true.
Kind of used this information already.
I mean, it's got the bit that we changed. That's if it's got that, then I'm pretty confident it's okay.
Yeah, just want to give this a quick glance.
We don't need those all undefined anymore, I suppose.
Good point. And the exclamation marks have been removed by the compiler. Then if the state is undefined, and that, and that, and that, I believe in that. I believe in this. I don't really need these rules. And yeah. Oops. Okay. We got some ranges. And all the ranges have numbers.
Okay.
So if my theory is correct, there are ranges that overlap. As in, one contains the other completely. And we need to deduplicate.
I'm not so sure that that's going to be possible. I mean, there are some overlaps. I can see some already, but not. It's like overlaps, but not in conjunction with the other ratings.
Maybe by construction we don't have this problem.
Yeah.
Let's suppose that we don't have this problem and deal with it if we get the wrong results.
Mm-hmm.
So,
and then just count our combinations.
Yes. So for each of the ranges, I now have to think of how many parts are there in this range. And then I have to multiply all the results. So what I'm going to do is, I'm going to map, and I'm going to reduce. I'm going to start with 1, and I'm going to get my product and my part, or not my part, my range, or not even that, my parts count. And I'm going to multiply my product by my parts count. Then in terms of mapping, I am mapping a range, and I need to produce a number. My number is...
Well, you're mapping a bunch of ranges, and each range has a bunch of range
of ratings.
Yeah, but there are also ranges.
And I guess that's the problem,
rating.
right? That's the problem. I'm calling this range, and I should be calling it like the parts range or something.
Range of range? No, it's not range of ranges. It's just a list of ranges.
But let's call it range for the time being, or maybe not. Okay, let's bite the bullet. Let's bite the bullet. So let's go over our program and find, why are there 3 modified files? Okay. And everywhere where we see range, let's rethink what it is exactly that we need. And I suppose that in many places we will want to rename this into parts range.
Yeah.
Ranges.
Well, they're not parts, they're ratings, aren't they? Is it what's a part again? In the description?
A part is one of these.
Okay.
And
so,
a rating is one of those.
So it's ranges per rating, isn't it? Yeah.
But we are talking about ranges of parts, right?
Parts ranges?
No, because I put it singular here, so we'll get the singular and the plural. So here we want to change. Oops, no. Backtrack. I goofed up. There. This we want to replace. This we want to replace. And then a stage. So we want to replace that. And this
is correct. That range.
It is correct.
Now you need to use parts ranges for pushing.
Here. And there. And there, and there. And there, and there, and there, and there, and there, and there, and there. And there, and there, and there. And there. So now if I console log my parts ranges, I still have the same result. We didn't break anything. So here I will be doing that, and this is that, and then each of my parts range is now one of those. So I will object values, which will give me these, and then I will map
range.
I take it back. I'm gonna write this line in a different way. I'll save this for later. And this is not my parts count. This is my parts range. And then here I will do the thing that I was writing. And then here I will reduce with 1, and this is going to be my product and my range, and I'm gonna take my product and times my range and minus my range start.
Get your parens in there.
Thank you. Let's reread this.
I feel nervous about the overloading of rewriting of this variable name, but it may not matter at all.
Yeah, last time you were nervous about this too, but this inner product does not need to interact with this outer product, so renaming the name, reusing the name should be fine. Let's see what we get.
Okay.
We get a large number.
We do want a large number.
No, we are getting...
That might not...
When I say large, I mean large. And we are dealing here with the example input. So we know what the answer should be. It should be this. Which is not what we are getting. Because this is 167 and this is 105.
Wait, do you not need to add them up? Here.
I don't think so. Let's think about this from the bottom. Say what you're gonna say.
It's all the combinations, right? This is giving you a bunch of combinations each time, so you need to add them, I think. Because you're not combining these with all the other combinations. Like each of.
So what you're telling me is that this should be a 0, this should be sum, and this should be a plus.
Yeah.
Okay, and you are right.
Oh,
we are better, but we are still not there.
Oh, okay.
I'll put the goal here so I don't have to keep alt-tabbing.
Yeah.
And the goal...
So if we just take off 2 billion from our output wheel every time, should be correct.
And this is the real.
Add in some constants.
It's interesting because we are close enough that, like, we are in the ballpark. Isn't that curious?
Yeah, that's not very inspiring in some ways, because like sometimes you'd hope that it was like a stupid mistake where there's just like, oh, it's totally just far away, so it will be an obvious fix. But this seems like it's more likely to be. I do wonder, I know this sounds stupid, but could any of these output ranges be invalid?
We have discarded invalid ranges when we did this.
Yeah.
So it never gets to the accepting part.
Okay. Okay.
So now I can think of two possibilities. Number one is simple. We have an off by one mistake somewhere in here. Number two is we need to deal with the deduplication or the overlapping ranges or the embeddings of ranges within ranges, however you want to think about that, because we are going over. We are going over. So we know that we are overcounting. So we need to remove cases, and either off by ones or embeddings of ranges within ranges could lead to overcounting.
Is it an issue that we're starting with like 1 to 4001 because it's not actually a constraint?
Yes, it is.
I mean, not for that reason, but just like how do I express this? It's because we're being explicit about every single range there, every single part, every single rating.
We have a different number when we put that there.
Put what where?
If we put 4,000 instead of 4,001, we get a different number, which is further away from the truth. So I suppose they mean, because the problem that I'm having here is a fundamental problem in the writing of the question. When they say minimum and maximum, is it inclusive or not? I supposed initially that it was inclusive, but it could be not inclusive. But not being inclusive undercounts. And it leads me to, it undercounts by a bigger value. So it leads me to believe that they meant 4,000 inclusive, which means that we have to write 4,001 here.
Yeah, I agree with that 100%.
But you were trying to convey a different point, which I didn't get. So can you explain again?
Yeah, it's a half-formed thought, so you might have to bear with me. But it's about sort of like implicit and explicit ranges. And we're being very explicit about what ranges are in each of the states. But I'm just wondering if no, I guess, yeah. No, I guess that does make sense. No, my thought isn't really working out, so.
So let's start with the easy thing, which is to just do a look over to see if there are off by one mistakes.
Oh yeah, we could have to revisit this bit, which we never fully analyzed.
Yes. So how about we do that? So we are dealing with an initial given range. We are dealing with a rule that will say something like, take everything that is less than, and we want to cut things out because we are here in the else part of our condition. So we are concerned with everything that does not match the rule, because if it matched the rule, it would have been in here.
So, yeah, in this operation, so we're actually looking at this clause first.
No, let's not do the double negative mistake. Let's not do the double negative mistake.
Okay, fine.
We are doing the else case. So I should not be saying this then. We are just interested in that.
Yeah. Yeah.
So my operator being greater than, which is not the case here, I'm looking at this part. And what I want is to keep my start. Oops, that's already a problem.
Yeah, this looks like the root cause issue.
No, I think that our initial logic was right. We want to keep stuff. No. From the top, people. Jeez Louise.
Yeah.
We have the case in which the rule applies over here. Now we are dealing with the case in which the rule does not apply. So we swapped the operator but kept the rules. So we don't need to look at this line anymore. Let's just look at this line. Does it comply to this result? The start is kept and the end is truncated. That's right. How about the other case in which I am interested in this region? Then, because the range is non-inclusive, I skip one and I do this. So now it is operand plus one and then, oh yeah, I think I believe in this.
Okay. Should we do some smaller examples then, like smaller inputs, like crafting ourselves, see if we can break it?
we could do that, and I thought about doing it, but I find that it's a bit complicated to think of the right answer, even by hand. So what I was thinking is that perhaps we could look at the parts ranges that we end up with and see if I can find an embedding. If I can find an embedding, then I have proved my point. And there are not so many. So let's test this 2 by 2, I guess. Well, there are not so many, but there are enough that it's going to be annoying. But I can see, for instance, that these two are not an embedding because the M doesn't match. Now let's consider these two. That's not an embedding because the S doesn't match. Now let's consider these two. In this case, the M doesn't match. And these two, the S doesn't match. And in these two, the A
S
doesn't match.
And the S.
It's going to be complicated to work this out by hand. But perhaps writing the code... Perhaps writing the code for this is not so difficult. So I'll try and write it. And if I got it right, then we're going to have a good result here. And we are back into the stage where this is our output. So we are overcounting by this much. This much. Wait, we are undercounting now. Ah, wow. We are undercounting now. So what did I change in the code?
Are you sure we're undercounting?
Yes, because the goal is, let's do it from the top. The goal is this. And ours is that. And they differ here, so we are now undercounting. Because 2 is less than 4. So did I change something in the code that made it break?
Those look like the same numbers. Maybe you just pasted the goal and the real into the wrong places.
You mean before or now?
Before. Could always go back on the YouTube live stream to check.
But now we are undercounting, so my idea of embeddings is flawed.
Yeah.
I'm throwing things at the wall now. It's one. What is a goal? What the goal is 1674, and we are 1672. One 674. Could it really be enough by 1? The difference is small enough that I feel like it could be enough by 1. And if the problem is enough by 1, then we don't have to deal with this part. We can console log our parts ranges and come up with examples by hand. So, for instance, what would happen if I have an input that does this selection of S or accepts, where S always rejects? Then I should get a range isn't that something?
Is that because you never have? Yeah, but is that because I mean log the output of what the parsing is doing? Because I think we maybe don't handle that case where well maybe there's no commas. It looks good. Are you referencing PX? PX doesn't exist, that makes sense.
No, not S. PX and PX.
Mhm.
Okay. Thanks for catching that. And here is our output. Does it make sense? It starts at 1, goes up to 4,000 in the X, M, and A ratings. And on the S rating, if it is less than or equal to, it's an off by 1 mistake. Because you see, it rejects, and I don't know why I put another rule. It could just have been that. This is the simplest rule that will demonstrate my problem. If it is equal to 1352, it should go into the accepting stage, and it's not going there. It's an off by 1 mistake.
No, isn't it? It is going to the accepting state.
Wait,
That
is
is
it?
that what we.
It is. It is. It starts. The start is inclusive. Okay. Yeah.
I guess
You're
try
right.
the opposite now. Yeah.
And that is doing the right thing as well.
So if S is greater than 1351, then yeah.
And if it is equal to 1351, it should be accepting. It isn't.
Which it is.
No, this and is not inclusive.
Oh yeah, that's true. That's true.
It is an off by 1 mistake. Now, where in our lovely code would that off by 1 mistake? It's on the end. And it is...
It's when we're clipping the end.
We are clipping the end with a less. What is our input? Is it less than or greater than? We are clipping the end with a greater than, and we are going to the else case. So we are clipping the end with a greater than, and we're going into the else case. So this end should be +1.
Yep. Don't forget to fix the one below as well.
No, where? Here?
So there's. So you did maybe the wrong one, because there's two. No. There's like, this is the else case, right?
Yeah.
But you want to fix the, like, these should be the same. The else case and the if case.
So
like,
what you're saying
yeah.
is that here I should change it as well?
865. Yeah.
Well, we get the right result now. What happens with the...
May as well run it with the...
And we are still not quite there. But now we are here, which is closer.
But it's overcounting.
And now it's overcounting. But I am... we could look at embeddings, but given that we had one off by 1, I'm sure that we have more off by 1s. So I would just work out everything with smaller examples. So, given this small example,
let's check that we didn't break the first case, which was working.
Yeah, so here I accept if it's greater than. So I expect to see a start of 1352. And I do. Now let's do a less than. And I expect to see an end of 1351. And I don't. So in my then case, with a less than, I should not be adding 1.
Okay. So they are different. Okay.
Now, for the else case, let's review it. I expect to see a start of 1351. And I don't. So that's wrong.
So this is saying we need it to be, if S is lower than reject, so we need it to be greater. So it needs to be 1351. Yeah.
Yeah, and it is not.
So the else.
So the else in the case of the less than should not be doing +1.
Okay. Yeah.
All right, and then a greater than, and we should be seeing an end of 1351.
It makes sense that they're not symmetric now, thinking about it.
And we don't. So there is, let's review if I have the right assumption. If S is greater, reject. So S of 1351 is accepted, so the end should be 1352. That's right. Can you explain to me why you see this and you think it makes sense?
Yeah, because... Sorry, I'm getting a call at the same time. Yeah, because, like, if you think about... you have this range, and somewhere along here you are inserting this, and like it's going to be uneven. How do I visualize this? Like if you're splitting it on one way, you're gonna, because it's like, otherwise you'll end up with this. If it was symmetrical, then you would have this, you would have like a gap in the middle, right? You see what I mean? Because you're splitting, like if you're splitting on the cell, then you're like picking one cell out and then you're like either side of it. But if you're not splitting on a cell, if you're not taking out a cell, then you have to like have an asymmetrical thing where
I thought that the asymmetry that you're bringing up is the asymmetry of start being inclusive and end being non-inclusive.
Yeah. But that's not quite how I was thinking about it. I think it's more that we're like splitting. You can't be doing this with characters though, because it doesn't quite work. Because you're splitting in between the characters. Maybe if I did like so like you have a character, then you have a space, then you have a character, then you have a space, then you have a character, then you have a space, then you have a character. And you're coming along and you're splitting on this one here.
Mm-hmm.
So this is going to be like up to this side will be, if this is I, it will be I, and this will be I plus 1.
No, but in both cases, we want to have this,
yeah,
because when it acts as the end, it's non-inclusive, and when it acts as the start, it's inclusive. I'm changing some code around to make it more to my taste. given that our idea of simply swapping this does not work. I swapped the clauses around, and then I kind of like it better. Yeah, I like the way that this reads, because think about it. If we have a less than, accepting is take the start up to the rule operand, and reject is take it from the operand to the end. Then greater than is take it from operand +1 to the end, and reject is take it from the start to operand +1. So I like the symmetry of these two things. And with that, and with this, hooray!
Great.
Good job, everyone. What an awful off by 1 day again.
Yeah, interval math is always like off by ones, isn't it?
Yay! We did it! That was day 19.
Nice one. Day 19.
Ah. They're just plotting stuff. And the problem of embeddings is not going to happen because there are no cycles. I think that's the argument, right?
Yeah, I guess we never checked if we ever hit a cycle, but yeah.
Well, we kind of checked for cycles in the visited workflows.
Yeah, but we never checked if that ever was true.
Yeah.
Like if we ever needed that has.
Correct.
Could you try?
Yeah, we don't need that.
Okay. I guess we did kind of check in part 1 and we didn't hit that case, so maybe. Yeah. But maybe it was just designed in that way. Seen this meme before.
Relatable. And this is yesterday.
With all the squares. Rectangles. Pretty cool. So, does it work just the same for, like, you know, the tight loops? The rectangle strategy? I guess it does.
We are not talking about this day.
No, yesterday's. Just like the Green's theorem strategy, it works just the same for like a tight hairpin where the borders are. Yeah, I'm sure it does, but
Can you?
Because you just go down.
Can you teach me how to draw what you're talking about?
It's kind of obvious to me, to be honest, that it will work now, but like maybe it's something that would. But so like if you like create a line, 1 square right, then 3 down, then 1 left, and then all the way back up.
Let's see. So I will go to the right, and I will. Did I tell you that zoom on the trackpad doesn't work very well in this app? So I'll start by counting the initial node. Then when I go to the right for 1, I count it. Then when I go down for 1, 2, 3, I will count everything to the left of it. Then when I go to the left, I do nothing. And when I go back up, I trim stuff to the left.
Yeah.
It works.
Yeah. Yeah. Cool.
Let's see if there is something surprising here. So they are transforming the inputs into a Python program and then execing.
Mm-hmm. That is cool. It's very concise.
And for part 2, we know that between each combination, blah, all outcomes will be the same.
I mean, he's still doing the range interval stuff. By the looks of things. This is just calculating the end result. Where is he?
Splits. The person is just instantiating, right? Oh no, no, they're working with ranges. These are the start and end nodes of the range.
Mm-hmm. And then he's going through all of those splits.
What is in underscore? It's a special
I don't
Python
know.
thing.
I do not know.
Maybe it's a special library that they wrote for their own advent of code downloading and stuff like that.
No, because he hasn't imported anything. There's something special about that in underscore thing. What is that? What could that be? It's an operator. No, it's not.
But that's another library
Yeah,
thing.
yeah. Not sure.
I think it's their personal thing, and
I mean, we could look at his repo, I suppose, but
well, they don't provide one.
what is this Topaz paste that everyone's decided to use?
It is created by Eric, and it's recommended here in the instructions.
Okay.
Maybe not here in these instructions. It is in these instructions. Now, why we prefer this, I don't know. The only advantage of this is that it does not store the code on the server. This is the code.
That's cool.
Yeah, it is using, I think, Z standard or Brotli to do very aggressive compression and then putting it as, like, let's say, base64 encoded or whatever in the URL.
It's not always, like, for such small bits of text, it's not always that beneficial to compress it.
You would just put the source in the URL?
Yeah.
So let's see.
But all like use a compression algorithm which is specialized. I was thinking of making one for small bits of text. You could have like a Huffman encoding tree, which is like part of the JavaScript. And then now that you have that map like stored, you know that most languages aren't going to have lots of special characters. It's mostly ASCII. So like
you would use the same
like,
same Huffman encoding for every compression. So you wouldn't need to keep the table in the encoded data.
Yeah. And that way, yeah, you save space. And but if there are any special characters, you just like base64 encode them or whatever.
I have seen that before. Fine. When I was doing Kasha, my packaging tool for Node.js, people wanted me to use Z standard and Brotli. And I looked into this, and I don't remember if it was Z standard or Brotli or something else, but there was a way of like fine-tuning the algorithm for the kind of data that you know you will see, and then you can distribute this as part of like the setup. So maybe in my Cache tool, I find that most executables have a certain pattern, and then I specialize it, and then I guess in the case of Cache, it's not really ideal because we are installing this on machines that we don't have access to, right? It's on machines of the users. But if you had a pool of servers that you know you will be deploying multiple versions of your app to over and over, you could distribute this mapping only once, and then each compressed file would be much smaller. And yeah, it is for when you have really a lot of servers that this comes in handy, but it is something that has been done.
That's I'm sure it has been done, but I never saw that as an option. I mean, it's specifically for small bits of text, like, you know, compressing. Yeah, is it standard? I mean, I never really read the docs probably, but yeah, it'd be cool to see if you can provide a
Yeah,
tree or something.
this is exactly what you're talking about, David.
Yeah. Offers a training mode. That's cool. And how'd you do it?
I suppose you train with a lot of JavaScript, then when you throw a very small snippet of JavaScript, then it will be able to pick up more similarities between parts of the code. Because the problem with small data compression is that you don't really have a lot of to go off of to create your Huffman encoding.
Yeah.
So you have to train, and then you have to provide that model, let's say, and then you can.
I more mean like how do they like give you? Is it using their CLI? What do they give you back a file that you need to store? Like how do you?
Well, it's a dictionary. How it's stored? Probably a command line flag and a separate file somewhere.
Yeah, that's cool. Yeah, there you go.
There you go, David, discovering what is pretty much the best kind of compression that we have right now, right? This is maybe perhaps not the best, but it's among the best, and David is creating it from first principles.
Oh
yeah. Eval could have simplified the parsing.
I mean, I reckon there are maybe some languages which would have just worked as well, like which actually have that syntax.
Yeah, I call it Christmas. Put it on the Christmas execution binary, and you'll get your result.
Yeah, I totally didn't see that it was the Christmas letters.
Wait, you did not?
No. I only just saw it.
Really? Because when I was reading the problem, I read XMAS, and then I said like, haha, Christmas.
I even missed you spotting it.
Okay, a recursive function that returns all the ranges of values that would be accepted. So it's pretty much what we did. They start with everything, and yeah, they did with recursion instead of a work list, but that's boils down to the same. Yeah, people keep saying that you're not supposed to make your inputs public, but we are making ours. We should revisit that at some point.
Yeah, it's okay. The government will come after other people before us.
Yeah, I don't know. I feel bad about doing it, but it's the most convenient thing to do. Recursively breaking down ranges. Yeah, so pretty much what we did, but perhaps a bit more
What's
terse.
the reason for like not making our inputs public?
Well, the reason is that first, like just plain intellectual property. Eric owns the materials generated by his website, and the puzzle
Yeah.
inputs are produced for each person individually, so they are intellectual property. And he, as the owner of the intellectual property, says that he doesn't want this to be shared. But more to the point, the reason why he has this position is that it could be, if you can amass a lot of inputs, you could create something like Advent of Code and then use it in commercial ways. Maybe you can use it, maybe it's just selling something that does what Advent of Code does, but like for coding interviews, and then you charge companies to use your platform. Or you could, I don't know, something like that, it's just a commercial use of the results. And for some of these programs, I suppose that generating the inputs is a significant amount of work.
I had a cool idea for coding interviews. So there are like a bunch of systems out there, but I thought that I could make one more where you go to the website, you press start, but before you actually get the problem, you have to start recording your screen and your face, and it's like it compiles your screen and your face into like one canvas, and then once that's all set up and the audio is working, then it shows you the problem, and then it like records it as you go and then uploads that. It would be a cool product to make, and relatively easy to make as well.
And the advantage is that the person cannot cheat.
Well, yeah, but the advantage is like there aren't like the problem could be anything. It could be like modify this open source repo, right? And also you don't need to be there with the person like guiding them through it. They're like working on their own, but they can like explain everything as they go, but you're like aware that they're how they think and how they do everything, but you don't have to waste your time actually sitting there with them as they like work things through, right? Yeah,
I see.
but normally these platforms, they're very constrained, so it couldn't be any problem. Like you don't see them like cloning repos and things like that. They're just like you do that kind of thing, but then you're just like coding one of the algorithm problems, which are like preset, and they have this like very complex functionality to like run Python code on their servers, or you know what I mean, rather than just like letting them use their computer as they would. Probably this thing does exist, but I'm sure there would be some companies who would pay for it too.
All right. The chat here on my end. Okay. Yeah, the chat was disconnected and now it's reconnected. So the audio was low and muffly. We addressed that. And I think with that, it's time for us to go.
Yeah, it's been a long one actually.
This problem, I would say, was satisfying. It was kind of a repeat of day 5, but I liked the parsing was fun.
Yeah.
And the way that the ranges work is different, because previously we had that whole mapping thing, which one could argue was more complicated than simply filtering.
Yeah, that's true. But yeah, it was nice. It's always good to get those off by ones with the range math, isn't it?
Yeah, the off by ones are awful. I wish there was some sort of solution for this, but I don't think there is. You really have to think through every case and draw some examples, right?
Yeah, I wonder if there's a better like a better way of visualizing it, but seems like a decent way.
Yeah. Okay, so with that, thanks both for joining us on the chat. Thank you, David, for coming up with this crazy idea of doing Advent of Code. And I'll see you again tomorrow, right?
I'll see you again tomorrow. Yeah, I look forward to it. Have a
Do you
great
know
day.
if you're doing morning or evening?
Morning's fine by me.
Morning's fine by you, you say. Okay, let's do morning then, but I may not be able to stay until like 1, like today, but we'll see.
Okay. All right. All good. I look forward to it.
Bye.
Bye-bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.